Thank you everyone for joining us today for the Wi-Fi 6E webinar with Aspire. Throughout the duration of the presentation, if you do have any questions, please feel free to use the chat box below, and we'll be sure to answer your questions at the end of the presentation. And I'll hand it over to Cody Harris to kick it off.
Thank you so much, Kathy. Thank everybody for joining today. Kyle Turk and I are happy to present, our kind of take on Wi-Fi 6, Wi-Fi 6E, some new technologies that we're very excited about. And the title of today's presentation is Hit the Fast Lane with Wi-Fi 6E. With that, my name is Cody Harris. My title is Director of Digital Architectures. So I oversee pre-sales engineering here at Aspire and focusing specifically on enterprise networking, wireless, IoT, and managed services. And with that, Kyle, maybe you'd like to introduce yourself?
Yeah, good morning, everyone, or good afternoon, wherever you might be at this moment in time. My name is Kyle Turk. I am a technical solutions architect in emerging technologies here at Aspire Technologies, and I love Wi-Fi. And I just want to make sure that you understand that today we want to just make you aware of the exciting new things in Wi-Fi and Wi-Fi 6E. And I want you to be able to take away some of the new technologies and the new things that are happening in this space. Cody?
Absolutely. Yeah, so with that, just a quick background on Aspire, right? So Aspire is a technical solutions integrator that specializes in matching business requirements and technical requirements of our customers to customer outcomes and goals, right? We do that by leveraging, a wide array of technologies, but specifically we focus on enterprise networks, collaboration, cybersecurity, data center and cloud, and finally the kind of pieces that we're here to talk about today, mobility and IoT. We do that by first bringing in solutions architects to all of our opportunities. Those solutions architects are, highly trained, very specialized engineers, a lot of time in the field, a lot of experience. They sit down with the customers, they understand their business and technical requirements, then they go back and do a needs analysis, kind of understand what technologies, what solutions could fit those needs, right, and create the outcomes that we're expecting to create. And then we kind of pass that on to the delivery team for actual delivery of those solutions, right? Our project management organization, they're kind of the glue that holds everything together. So they kind of operate as the conduit between the pre-sales and the post-sales team, and obviously stay along with the customer and be that advocate for the customer as the projects progress. We also have a 24/7/365 NOC. So all of the solutions that we'll talk about today, we do have the capability of managing them for customers that maybe want to focus on more strategic endeavors, or maybe they're a little bit light staffed at the moment, right? We can take the ongoing management of these technologies on for them. And finally, customer success. Customer success is critical to everything we do. Customer success is involved throughout the life cycle of our projects, and ultimately they're there to ensure that our customers are getting the best value out of the solutions that we're providing, and that customers are adopting the solutions that we are providing. So with that, here's just a quick agenda. So we're going to go quickly into the history of Wi-Fi. It's a relatively old technology. It's been kicking around for quite a long time. So we'll get into the history of Wi-Fi. Then we'll go into specifically Wi-Fi 6E, why it's so exciting, why it's so important. We'll kind of compare and contrast 6E to some other technologies that are out there, where the fits are, right, where the synergies are between 6E and some other technologies. And then finally, we'll jump into how to get started on your move to the fast lane, what Aspire can do for you, how we can kind of help you along that journey. And finally, we'll open it up for Q&A if anybody has any questions. So with that, Turk, I know that you've been playing around with RF since you're a teenager, right? So you literally lived this entire slide here. So with that, I'd like to kind of hand it off to you to kind of talk about your experience and the history of Wi-Fi as you see it.
Thank you, Cody. So yes, that's true. I've been playing with Wi-Fi for quite some time, and really back in the 1999s and the 2000s, is really when Wi-Fi started to take hold. People started deploying and building Wi-Fi networks first in outdoors, and then a lot of client-based indoor Wi-Fi networks. And really, it started with that 802.11b. Back in the year 2000, 2001, 802.11b, and then quite soon after that, 802.11a got released in an environment where the technology was first getting started, and the bands that the FCC carved out for these two technologies, or this technology specifically, were designed around ISM bands. So in the beginning, first we had 802.11b with 2.4 gigahertz, and this 2.4 gigahertz band is kind of a jack of all trades. In the beginning, the 2.4 gig band was used for a lot of things, industrial, scientific use cases for, you know, in the public eye. Some use cases were phones, video surveillance systems used it. We had analog phones, we had digital phones. So these technologies added a lot of interference to that band before Wi-Fi even got started. And the bands themselves were quite small. 2.4 gig really hasn't expanded since that first day, but it's really only 100 megahertz wide. And just for comparison's sake, a Cat5e cable, a typical Cat5e cable, is really just only 100 megahertz wide. Could you go to the next slide, please? Thank you. And as you can see, like when we first got started with Wi-Fi, we got these small bands that had a lot of use cases going on. Like I said before, phones and video surveillance, and really we only had 83 megahertz of total bandwidth to play with. And then they added 802.11a and some of the utilization in 5 gigahertz, and that wasn't overnight. It was slow to start. But eventually we ended up with what we see in front of us today, 83 megahertz of total capability on 2.4 gig. I mean, it's really only 100 megahertz, right? And 500 megahertz on the 5 gig band. And it's been a long time that we've been working on these two bands. The complexities and problems with 2.4 gig has seen us kind of migrate away from that and primarily use 5 gigahertz, because it really is the only place where we can get that added and extra bandwidth, right? Over the years of Wi-Fi, there's really only been two ways that you could get more bandwidth. One of those ways is by the modulation techniques, right? And the fact that 802.11b has every modulation technique that you could possibly throw a stick at being utilized in that one space, it causes a lot of legacy issues. And then the other way that we get bandwidth is by channel bonding, right? And as you can see in the 5 gig space, we can do that to some extent. But as you start bonding these channels out, you end up running out of space, as you can tell. When you start bonding from 20 to 40, you lose 25 and you end up with 12 channels. If you want more bandwidth and you bond to 80, then you really only have 6. So we're really running out of space. But what's really exciting with Wi-Fi 6 and Wi-Fi 6E is that they're adding a whole mess of channels. And really, this is a watershed event in Wi-Fi's history. And actually in all of FCC regulation history, because it's pretty straightforward. The simple fact that the FCC is providing 1,200 megahertz of free bandwidth, and all you have to do is buy an access point. That's pretty huge. The only other time they've changed the frequency spectrum this drastically for public utilization for free is, TV channels, when we moved from analog to digital. But to be clear, this is something that never happens, and it's absolutely astounding that they're cutting this much space out for us to use moving forward. Now, the other thing that makes this so groundbreaking and so awesome, and makes it so exciting at this time, is the fact that these are non-legacy spaces, which means that as we migrate devices into this space and utilize 6E, you'll start to realize and understand that everybody that's operating in this space are using the latest modulation techniques and the latest capabilities. So there's no problems with slower clients modulating at more inefficient techniques, causing you to slow your bandwidth down. Because when you're on 2.4 gigahertz and you're transmitting at 16 QAM or higher QAM, quadrature amplitude modulation techniques, you don't want to be interrupted by BPSK or something that's slower like that. Because in 2.4 gigahertz, everyone has to be heard, and when those modulation techniques happen, the radio has to change. But if we're all using the same standards in this new band, then it's going to be a lot cleaner, and there's going to be a lot less noise. And I think that's a really exciting benefit moving forward to 6E. And I think everyone should take note that this is probably going to be a really big impact to your environment, as well as provide you lots of additional bandwidth. But that's not really the only thing that Wi-Fi 6E has going for it. There are other things like advanced security and improved, capacity that I think, Cody, you have more information on and could provide us some more impact and information.
Sure, of course, yeah. So, when we moved along kind of that Wi-Fi life cycle prior, a couple slides before, right, a lot of times the focus was specifically on increasing bandwidth, right, getting more speed, right, more power. Wi-Fi 6, the intention here is obviously it has a speed boost, it has a bandwidth boost, no question, but really it's now capacity, right? So with MU-MIMO and other technologies such as that, we now have the ability to increase capacity by 4 times, right? More users on the network, less congestion, higher capacity is very important because as we know, as we have users kind of migrating off legacy wired connections and onto wired connections, I mean, just take a look at your laptop, right? Your laptop no longer comes with an Ethernet connection. The kind of primary computing device in the world now has become mobile phones, right? That mobile phone also does not have an Ethernet connection. So as we're kind of adding more and more devices that are wirelessly connecting to our networks, it's more and more necessary to kind of increase that capacity, right? Along with that is security, right? So look, anytime you're going to increase the standard or move the standard along, security has to be paramount. Wi-Fi 6 embedded in Wi-Fi 6 is WPA3, right? So that's the latest security profile within wireless. So as we all know, WPA2 WPA pretty easily crackable. WPA2 certainly possible to be cracked. WPA3 now adds kind of that additional layer of security so that we are ensuring that we're not going to get, have some sort of, hacker come in and gain access to the network when we don't want them to. Reduce latency, right? So this is very interesting, right? So now we're using deterministic scheduling. And what that means is that we are now, the access point and the endpoint are now scheduling when those devices will transmit, right? So previously in Wi-Fi 5 and older Wi-Fi technologies, it was kind of a listen and wait technology. And what that means is when your device wanted to transmit, say your phone wanted to transmit, it would open up its radio and it would listen to see if anybody else was transmitting on that channel at the time. If somebody was transmitting, right, it would wait. It would, there was a very specific algorithm that would determine the amount of time it had to wait, and then once that time was up, it would open its radio up again. And if there was somebody transmitting on that channel still, then it would wait and listen again, right? So what we're doing now is we're scheduling when those devices will transmit, right? So these devices no longer have to kind of open up those radios to listen. They know that at a particular timestamp, it'll be their time to transmit, right? Which is very interesting for many reasons, but not the least of which is we're now, increasing power, right? And battery life, right? So a lot of devices that we have, it's critical that, you know, the power lasts as long as possible, whether it be a mobile phone or some sort of IoT sensor that, you know, has a battery within it that needs to be, you know, replaced on a regular basis, or you know, some of these IoT devices have a non-replaceable battery, right? The battery will just operate for the life of the device and then it's over, right? So because these devices are no longer having to power on and off to listen to see if somebody else is transmitting at the time, that gives us now the capability to leave that radio off and therefore conserve that power for longer periods of time. And finally, improved interference mitigation, right? So this is affected by a technology called BSS coloring. So traditionally what would happen was, you know, you had some number of channels that your devices could operate on, could transmit on, right? And if there was interference, right, if you had multiple devices transmitting at the same channel at the same time, the system would have a really hard time determining which transmitter it was transmitting that data, right? So what BSS coloring does is it adds an additional component. It adds a quote unquote color to the transmission so that the access point knows, okay, you know, we are operating on this channel with this color. If it's blue, let's say, then it knows to kind of discard any transmissions that it hears that are within that channel and colored as red, right? So that gives us a lot more capabilities to kind of mitigate co-channel interference, which we all know as Wi-Fi guys is, you know, traditionally the bane of you know, Wi-Fi existence. And so, yeah, so those are, you know, some of the main benefits of Wi-Fi 6. And with that, now that we kind of understand the basics of Wi-Fi 6, Kyle, I'd like to kind of jump into, you know, these other technologies that we're seeing become more and more pervasive in you know, in the world, right? 5G and maybe some of the IoT stuff as well. I mean, what are your thoughts there on how, you know, those disparate technologies are going to interoperate?
Yeah, it's true that right now we're living through a very confusing time with specifically with RF wireless technology. And when I say wireless, I'm not really specifically talking about Wi-Fi. I'm really talking about, you know, 5G, Wi-Fi, LoRaWAN, you know, Zigbee, things like that, Wi-Sun. There's a whole array of technologies that are being deployed. We're not sure which ones are going to stick. But I think the direction that Wi-Fi 6 and 5G specifically are going to take, there's going to be a blending of these two technologies in the form of a sense of complementariness or a way to complement one another, right? So another aspect of this blending is not only you know, are you going to see 5G utilized by the carrier and Wi-Fi utilized by the enterprise, but you'll start to see that 5G starts to become privatized, right? And it gives end users the capability to, in the enterprise, add 5G services. So where you're utilizing Wi-Fi 6, you could also supplement that with private 5G. And there's a lot of developments from most of the major enterprise development companies and AT&T and Verizon. You know, very early last year, CBRS was ratified, and that opened the door for privatization of LTE and 5G deployments. On top of that, I think that in the IoT space, you'll see LoRaWAN take a big jump in utilization. I think they've got a lot of market share. We've got a lot of deployments for LoRa, and the fact that, you know, the devices can last long periods of time and send data, you know, 20 miles, 20 kilometers, that has a big impact on that vertical and that area of deployment of small IoT devices. So right now, I think we're kind of taking a step back. We know that Wi-Fi 6 is going to take a lot of bandwidth and a lot of capabilities and drive the enterprise market big time. But I think we're also going to see 5G have a big impact on the enterprise when it hasn't in the past. And there's going to be a lot of overlap. Yeah, truly.
Yep. Understood. Yeah. And so not to steal some thunder from the previous slides, but it's, you know, one of the things that I know you and I talk about and I'm very interested in is kind of this bundling of devices, you know, it's traditional kind of Wi-Fi access devices and IoT, right? So that's, it's very exciting for us because, you know, we're guys that operate in both those spaces. So to see those, that convergence occurring is very interesting, right?
Mm-hmm.
So yeah, next we wanted to kind of jump into kind of preparing your network for Wi-Fi 6, right? So Wi-Fi 6 very fast, right? It provides a lot of really good speeds. In the real world, we're seeing, you know, somewhere in the range of, you know, 400 megabits to 500 megabits per user, right? That's about what we're seeing in real world environments. Again, considering the device type, I mean, obviously newer device types could maybe exceed that, but that's the standard of what we're seeing now, or the average of what we're seeing right now. So if you consider the fact that you have maybe 400 megabits per second, you know, being sent, and then let's say each access point has 20 or so users on there, we're now able to push a lot of data through our network, right? And what that means is we have to make sure that the interconnections between our access points, our switching infrastructure, and our controller infrastructure has to be more robust than it was in days past. So now we're looking at M-gig connections between your access points and your access layer switching infrastructure. M-gig, you know, traditionally your wired connection was a 1 gig connection. With M-gig, you now have the ability to leverage your same kind of copper cabling infrastructure and achieve 2.4, 5, or 10 gigs of throughput on that single wire, right? So a lot of capabilities there, but you do need an M-gig capable switch and an M-gig capable access points. Now, obviously, the access points, all Wi-Fi 6 access points are going to be M-gig capable, but you have to make sure that your access layer switching infrastructure supports M-gig. The next level is going to be the connection between your access layer switches and your core or your aggregation layer, right? So we're seeing most customers kind of opting for 40 gig connections at least between those different layers of switching, right? And finally, you have the connection from your core or your aggregation layer down to your wireless LAN controller. Now we'll jump into the actual the wireless LAN controllers that Cisco currently offers. You know, and they are in the range at the highest levels of 80 gigs of throughput, right, between your wireless LAN controller and your switching infrastructure. So we have to make sure that as we're bringing on Wi-Fi 6, as we're bringing on these really highly capable access points, we also have to make sure that the underlying switching infrastructure has the capability to support those really high speeds. So next we wanted to jump in the kind of portfolio, the controller portfolio for Cisco. We'll start there in the bottom. I mean, you know, really what this does is this kind of starts out at the lower ends of customer requirements, right? So initially, you know, these are for very small deployments, the embedded wireless LAN controller added to the access point. That was a capability that was added a couple years ago, but they've been doing a really good job of continuing to develop it. And stabilize it, right? So for access point deployments under 100, you now have the ability to load a specific version of code on one of your access points, or really two of your access points, because you're going to want high availability. And now the controller code is now in that AP. So you are managing the entire wireless infrastructure from the wireless LAN controller embedded in that access point. Again, for very small deployments, you know, we're really scoping this out really for maybe 50 APs or less, right? Situations where it just doesn't make sense to bring in a large wireless LAN controller. The next level up, this is for, you know, situations where you maybe have 250 APs or less. Cisco offers you the capability to add your wireless LAN controller to your Catalyst 9K switching infrastructure, right? So we all know that the Cat 9Ks, you know, they have the ability to run applications on them through containers. So you can run a wireless LAN controller on your switch and have that wireless LAN controller operate your entire network. Moving up the stack, we have the Cisco the C9800L, CL I should say. So the CL is the cloud-based model. So as we have more and more users that want to migrate to the cloud, this cloud-based model is a software-only version of the 9800 controller, very similar to the 9800L, which is again, for kind of a medium campus, under 1,000 AP environments. And so you have both capabilities there. You have the ability to go on-prem with the 9800L, and then you have the ability to go cloud in the 9800CL. And then on the top, you have the big boys. You have the guys with all the horsepower, the 9840, right? So the 9840 is a wireless LAN controller capable of managing up to 3,000 APs, and it has connectivity of up to 40 gigs to your switching infrastructure. And then finally, the thoroughbred of the portfolio, the 9880. The 9880 supports up to 6,000 access points, which is quite a lot of access points, and it provides up to 80 gigs of connectivity from your access points. From your wireless LAN controller to your switching infrastructure. So next, this is the kind of big reveal, one of the things we're most excited about. I mean, Turk, I know you and I have been, maybe for about a year, we have been on various, whisper sessions with Cisco, various conversations with the BU. And what we wanted to know was, when will Cisco release a Wi-Fi 6E capable access point?
We're not whispering anymore. This is no longer a whisper. We are yelling at the top of our lungs. This is the new Wi-Fi 6E access point. I'm going to just say a couple things, and then Cody, I'll let you keep going. One thing to note here is it's got all the bands, and you can order it in several different variants. You've got the access point with 3 radios, the 2.4 gig, the 5 gig, and the 6 gig. And then you also have one that's 4 radios, 2.4, 2 5s, and a 6. Now, depending on how you split that up, will depend on how many streams and MIMO you get. One other thing to note is these radios, or these access points, have 802.15.4 technology in them. If you're familiar with Zigbee, that's pretty much what Zigbee is. Another application is 6LoWPAN or YSUN. Those are the IoT technologies, similar to Bluetooth, but not the same thing. A different way of modulating and transmitting those. These also have environmental sensors in them: temperature, air quality, humidity. That's pretty huge, considering that these things usually get deployed in your environments like all over the place. That's going to be pretty huge. I mean, you just monitor the temperature and air quality from that, and you have a very high resolution understanding of what your environment's like. And that's just an add-on bonus, right? And also, sorry, go ahead, Cody.
No. I mean, I was just going to talk about, that this is kind of that convergence of IoT and wireless that we were talking about earlier, right? That, now you can leverage. So traditionally, Turk, this is your world, right? But traditionally, if you wanted to, deploy a bunch of IoT sensors, you had to have a specific gateway, right?
Right.
So you would have some sort of LoRaWAN gateway, an IXM gateway. These sensors would then transmit all their data to this gateway. The gateway would then, convert the data and send it on the wire. So now we have the ability to leverage your access points within your environment to do that. It's pretty exciting.
Yeah, absolutely. I think also the everything is going to be dual 5 gig uplink ports, and as well power capabilities, right?
Yeah. So that's an interesting piece. I mean, I got burnt on this once on a I wouldn't say burnt, but Cisco considered it a feature, right? But one time I was deploying wireless. This is a few years back, and we were leveraging the multiple uplink connections on the access point, right? The unfortunate thing was that access point, only one of the uplinks was actually PoE capable. So it wasn't actually redundant, it was just leveraging that additional cable for additional bandwidth. And if for some reason your primary cable, or the cable that was connected to your PoE port, went bad or got disconnected or anything like that, that brought the entire access point down. So what they've done with this,
and that's no longer the case, right? That's no longer the case. It's dual power now.
That's right, which is very exciting, right? So now not only does that second cable provide additional throughput, but it also provides that additional capability to power that access point. So if you lose your primary cable, right, for whatever reason, you're not going to lose your access point in its entirety. So that was the big exciting news on the Cisco side. Obviously, you know, the Meraki's not going to be too far behind. So actually, in this situation, the MR57 was announced a little bit earlier, but I believe it will be available a little bit after. But the MR57 is going to be the the Meraki version of the 9136. It's going to have a lot of the same features. Obviously, it will be cloud controlled right within the Meraki dashboard rather than leveraging those controllers that we talked about in the portfolio earlier. But on this one, you're going to get the tri-band, so you're going to get the 2.4 gig radio, you're going to get the 5 gig radio, you're going to get the 6 gig radio. They have the capability for dual 5 gig support, right? So that 2.4 radio is really what they call an FRA radio, or flexible radio assignment radio, that has the ability, based on customer needs and customer requirements, you would have the ability to convert that 2.4 gig radio to a 5 gig. So you could potentially leverage 2 5 gig radios on this access point, as well as the 6E radio. It also has the the dual PoE 5 gig ports, right? So now it kind of has that power redundancy, which is so important. And then finally, and this sounds like maybe like not a big deal, but now what they've done is they've kind of converted the mounting kits from Meraki to be able to leverage your Cisco universal mount, right? So anybody that's ever deployed wireless, Cisco wireless is very familiar with the mount. I mean, Turk, you probably mounted 10,000 of these, and so for customers that want to migrate from a traditional Cisco environment to a Meraki environment, you no longer have to go in, pull that old mount down, right, pull out your old Meraki mount, replace the old mount with the new mount, and then mount the Meraki device on the Meraki mount. You can now leverage that old Cisco mount or the traditional Cisco mount in order to mount your Meraki APs. And I think it also has the IoT, right? Yeah, yep. So it also has IoT capabilities. For this one in particular, it's going to use Bluetooth Low Energy, so it does not have the capability on the 9136 side for the 802.15.4 radio. This is going to use Bluetooth Low Energy, but there are a lot of IoT devices that leverage BLE, and even just in the Cisco portfolio, right? Cisco has 3 sensors, and so any of those 3 sensors can be attached to this access point and leverage this access point as the gateway. Okay, so with that, now we would like to kind of transition to what Aspire can do for you. Right. So, as we mentioned before, we have a lot of experience in this space. We have a very well and thought out process of how we deliver solutions to customers. That having been said, specifically in the wireless space, we have a lot of capabilities that can kind of help customers along their journey. Right. So site surveys is number one. We currently leverage Ekahau. We have expertise and certifications in Ekahau in kind of the use of that device or that capability in order to optimize wireless solutions within customer environments. Wireless design, so we have a ton of experience in different types of environments. Turk, I know, you kind of started off with long-range point-to-point connections and like mining and retail and warehousing, manufacturing. Right. We have a lot of customers with a lot of varied environments. And obviously, each one of those varied environments, as we come in, as we understand them, as we understand how the RF operates within those environments, that kind of just continues to build in our experience and our ability to provide these solutions to customers that have similar situations. From there, once we have the wireless design, obviously we go into configuration and deployment. So this is, configuring the access points, configuring the wireless LAN controllers, the switching infrastructure. Maybe if you have ICE within the environment, right, you want to do network emission control, DNA spaces, coming in, configuring these devices, optimizing those devices for the particular customer, for that particular environment. In addition to that, RFI troubleshooting. Right, so we have Cisco comes to us regularly with for situations where another partner or maybe the customer themselves have deployed wireless and it's suboptimal, right, for any number of reasons. So very regularly, Cisco kind of comes to us and says, can you get involved in taking a look and providing your recommendations on what we think could resolve the issue. So that's a big component of what we do. And then finally, 24/7/365 managed wireless services. So, we have a lot of very large accounts within our managed services team that we are managing their entire wireless environment, from the access points to the controllers to ICE and Prime and DNA Center and so on and so forth. So we kind of run the entire gamut of capabilities from a Wi-Fi perspective. And that allows us to, again, affect that customer outcome, right? Affect that business outcome. We want to take the kind of technical components off of our customers' plate so that they can focus on their strategic endeavors and ultimately making money, right? So last piece here, this is the current wireless team. So Kyle Turk up there on the left, I mean, all of us together have a combined, it's over 50 years of experience. Kyle's CCIE is in security. He has that CCIE for 10 years. I mean, as we mentioned before, Kyle's been kind of playing around with RF since he's a teenager. Cody Harris. So, Turk and I have spent, a good portion of the last 10 years talking about these technologies, talking about these solutions, understanding how they operate in the customer environment. So, we have a lot of really, really strong capabilities from a pre-sales perspective, know all the right kind of questions to ask to dig in to optimize those environments as much as possible. Down there on the left, Eric Ladowski. So Eric Ladowski has a CCIE in wireless. There's not that many in the world. Last we checked, there's less than 400. And we have one of those guys on staff. And you'll notice that we both are Meraki Masters. It turns out that even though we were at different companies at the time, we both went to the exact same Meraki Master training week. And so there was 130 previous Meraki Masters. So I gave him 131. I took 132. And then in the middle there, Keith Heckel. Keith Heckel's another one of the pre-sales engineers here at Aspire. He's one of our kind of Ekahau masters. He knows all the ins and outs of Ekahau and kind of going in and surveying customer environments to optimize the network. And finally, Hamed Baba. So Hamed is one of the guys on Eric's team. He's a deployment engineer. He's been doing this for, right about 10 years. He comes from a background of long-range point-to-point connections as well, kind of similar to Turk, and is kind of, also a access layer, let's say access style wireless as well. So that concludes the webinar portion of today. We would like to open it up to any Q&A. Kathy, any questions today?
Nothing that came through the chat at this point.
Okay, very good. Now, I did have one question, Kyle, and that is in terms of backwards compatibility, right? So, we both know in the wireless world, backwards compatibility is huge. It's paramount to the success of the deployment of any sort of wireless network, right? Now, in 6E, there seems to be a lot of confusion because you hear that Wi-Fi 6E access points aren't backwards compatible, right? So maybe you could kind of jump in on that and describe, what's going on there and why people are saying it's not backwards compatible.
Yeah, so I think the confusion comes from around the band itself. Obviously, if you don't have a 6 gigahertz transmitter or receiver in your device, you're not going to be on that band. So while the new APs have the ability to transmit on 6 gigahertz, they still have the ability to talk on 2.4 and 5 gigahertz, right? And they still have the same capabilities to utilize all those other legacy technologies. But the only place that isn't true is for that 6 gigahertz band. So if you buy an access point and it has 2.4, 5, and 6, your clients are not going to be able to roam on that 6 gigahertz band until they have that capability. So I believe that's what they're talking about when they say it's not backwards compatible. But in that case, that non-backwards compatibleness is a good thing because you don't want older clients coming on that new band and spewing a bunch of garbage. Not that it's garbage, but it's not as efficient as the new band. So.
Yeah, understood. So is it fair to say that the Wi-Fi 6E access point is backwards compatible, but Wi-Fi 6E itself, the 6 gigahertz band obviously is not backwards compatible.
Well, I believe the ones that Cisco have are capable and backwards compatible. But
Right.
that might not be true for all access points out there. There might be
Good point.
6E access points that are only doing 6 gigahertz. But
That's a great point.
I doubt that there's going to be that many of those out there. So I think everyone
Yeah.
should be fine with the new advancements and the backwards compatibility capabilities. So.
Understood. So we would be talking about an access point that didn't have the 2.4 or the 5 gig radio, right? Just a 6
Right.
dedicated. Copy that. Okay, great. Okay, so that was all the questions I had. If there's no more questions, if anybody on the webinar has any interest in kind of talking to us and digging in a little bit deeper on these technologies, please feel free to reach out at info@aspiretransforms.com. Kyle and I are always available to have conversations with customers to kind of dig in, understand what the requirements are, where the fits could be between these technologies and the customer needs. And obviously also, go visit the website at www.aspiretransforms.com for more information as well. And with that, I'd like to close the webinar. Thank you.
Thank you, guys.
Thanks, Katie.